Latin geometry students. Today we're going to talk about the most basic parts of geometry, the beginning of geometry itself, the things we use to build every shape that we will talk about in geometry, and we'll be talking about points, lines, and angles. Okay, first off, a point is not an object. People tend to think of a point as like a ball or a marble, but it's not. Like a ball might be 2 inches wide or 1 centimeter across. A point, on the other hand, has no dimensions. It's just a location. It has no dimensions at all. No length, width, height, depth, none of that. A point just gives you a location for something. We name a point with a capital letter. For example, this point here, if we wanted to name it, we call it point A. We just write one big capital letter for it. It would be important to remember the naming for stuff. It'll save us a lot of time rather than writing out words like line and point if we just use a one capital letter for the points. The second term we're going to talk about is a line. Now, in geometry, a line means something very specific. Most people are used to all of these being lines, but for geometry's purposes, only one of them is a line. If you look at these 4 lines, they're all different because of the arrows that they have on the end, but only one of them is a line. Which one? Well, it's this one. This is a line because we define a line as looking like this and going forever in both directions. This arrow over here on the left says this line keeps going on the left. It goes forever and ever and ever. That's what that arrow says. And the same on the right. This arrow on the right is indicating that it keeps going to the right forever and ever and ever. None of these other objects have an arrow on both ends. They are all slight variations on a line. For example, this first one up here, it stops here. There's no arrow, so it means it stops or starts right here. And it goes across and it goes here and then stops or starts this way. It doesn't matter which point is stopping or which point is starting. We call these places where they stop or start endpoints. This version of the line has an endpoint on the left and the right. We call that a segment. Versus the second one, we have an endpoint on the left and then an arrow on the right. It says it has an endpoint here, it starts here, and it keeps going on forever to the right. That's a ray. One that goes on forever in both directions, we call that a line. And this last one, take a second and figure out what this one is. It's one of the ones that are above. Yeah, and it's a ray. It has an endpoint here on the right side, and on the left it keeps going forever and ever. Now, technically, the word line in geometry does not have a definition. It's what we call an undefined term, but we're going to give a loose definition here anyway. A line is an infinite set of adjacent points. A couple big words there. Hopefully you already know what infinite means. It means it keeps going and going and going and going. There's lots of points. So many points you can't count it. In fact, there's an infinite number of points. And they're adjacent to each other. That means next to each other. So a curved line like this, these are all points next to each other. This would fit in this definition. And a straight line like this would fit in the definition as well. However, for geometry, for this class, we're going to only be talking about straight lines. We're not going to bother saying the word straight. We're going to say the word line. If you hear the word line, we are talking about a straight line. Okay, so here we're going to talk about a line, a segment, and an array. If I wanted to draw a line here, to describe where to draw the line, I would need to give you 2 points. 2 points to connect on that line. And it could be any 2 points. For example, if I wanted you to draw this line, I could tell you connect B and H and then extend it to the left and right. Or I could tell you to connect H and E or B and E. And it doesn't matter what order I tell you them in because they're not endpoints. They're just other points on the line. So if I tell you to draw a line between B and H, it's the same as me telling you to draw a line between H and B and any other point on that line. That's not the case for the other ones. For a segment, to describe how to draw a segment, I can't just say, oh, connect it, dots and extend it. I got to tell you where it starts and where it ends, because that's the key feature to a segment, is it has a beginning and an end. So to describe a segment, I need to describe it just using the endpoints. So this here would be segment FG or segment GF. We don't know which one's beginning, which one's end. But to describe a segment, we describe it with the endpoints. For array, this is the trickiest one. You start off describing array by where does it start and then which direction it goes. Like say I wanted to start up here at point C, I could say, okay, start your array at point C, and then I need a second point to tell you which direction to go. So I could call it ray CE, and that means we start at C, go through E, and keep going, or CG, or in this case, CA. It means start at point C and go through point A. Now, that seems pretty obvious, but that becomes important when we talk about naming these objects. All right. First off, a line goes on forever in two directions. When we name it, we just name it with 2 points that are on the line. It does not matter which 2 points. Here, this line has 4 points. If you use all 4 points to name it, you're wrong. Because we don't need 4. We only need 2 to tell which direction it's going. So if I asked you to name this line, you could name it with any combination of 2 letters on the line. You need 2 points. So we could call this line, line AB. Now, in geometry, we don't want to write this out. We use a lot of symbols to shorten up our writing. So instead of writing out the word line, I'm going to use the points A and B and draw a line above them. And like this. This is line, and you can see I've drawn a line above the letters A, B. So it's the shortest way to write this out. We skip writing some words with this, and as the year goes on, we get into more complicated shapes. The shortcut symbols we use for writing shorten up more and more, and they get make it a lot easier to write it out because our words will get longer and longer. Okay, but line AB, this is not the only name for this line. As it says, you can pick any 2 points to name the line. You could call this line, line BA. See, order doesn't matter. Or line AX, or line XA, or line ZX, or over and over. There's lots of them. All of these are correct names. It's really hard to name a line wrong. Number 1, pick 2 points. Don't pick 3 of them. Pick 2 points, put them on the line. Number 2, draw the little symbol for the line above it. Make sure to include those arrows so we know it's a line, not a segment. The backfire here, the one thing that can go wrong, is if you're comparing your answer to somebody and you say, oh, the answer is line AB, and they say, oh, it's line ZX, you got to know, oh, those are the same line. Now this picture shows a line, line AB or line BA, but sometimes our pictures get very, very crowded. There's lots of triangles and circles and stuff floating around the picture. So we have a shortcut for naming lines that is not the preferred way to do it. It's not the first choice, but you can do this and we'll sometimes see this. If the picture's so crowded that we can't have this many letters in the picture, and obviously this is not a crowded picture, but if it is a crowded picture, sometimes instead of calling this line AB or line BA, we can shorten this up to a single cursive letter and write the word line for it. So we can call this line L or line AB. So that's the shortcut naming, which shows up when our pictures get more crowded. All right. One other word that you should know here is the word collinear points, or the phrase collinear points. Collinear, linear means line, co means together. So together on the same line. If things are on the same line, we call them collinear. Next, we're going to talk about naming a segment. A segment has both a beginning and an end, and ends on both sides. And that's the key feature to the segment. So when we name a segment, we'll name it by those end points, the point where it starts and stops. In this case, in the picture, which 2 points are the end points? So if A and Z are our endpoints, we want to call it segment AZ. Again, instead of writing out the word segment, we're going to write the letters A and Z and draw a segment above them. Now notice, it looks very similar to a line. It's important whether you include the arrows on the end or not. Some people put points here on the end so it's clear that they're not arrows. But this is a segment without the arrows on either side. This is segment AZ. Since it doesn't matter which is the starting point, which is the ending point, we call them both endpoints. Doesn't matter what order we put this in. So instead of segment AZ, we could also call it segment ZA. Whoops. Okay, finally naming array. Array goes on forever in one direction. As we said before, to name our array, we're going to start with the end point. So in this picture, which point's the end point? That's right, we start with point A. After you have the end point, you can name any of the other points on the array, but only one of them. It doesn't matter if we start at point A and go through point X, or start at point A and go through point Z, it's still the same array. It's starting at the same spot and going in the same direction. So we only need 2 points, the end point and some other point to tell you the direction. So I could call this ray AZ, and again, instead of writing it, I write it this way. So writing out the word ray, we type AZ and draw a ray above it. Now the ray symbol is important. It's got an arrow on one side and not the other. And it's going to have to match with the endpoint. You could also call this ray AX. We started with the endpoint and then another point to describe the direction. However, people tend to mix up the naming of a ray. This is the first place where people get stuck in geometry. If I ask you to name this ray, take a second and see if you know the answer. A lot of people get this backwards, but this is how you write it. This is ray RL. We start with the endpoint, we go through point L. We draw the arrow going to the right. And a lot of people would think, well, that doesn't make any sense. A lot of people would probably feel like this. If you're thinking you don't get it, take a second, follow along. The rules for naming an array can be slightly tricky, and it's easy to mix this up. To name an array, number one, always start with the endpoint. What's the endpoint for this ray? It's point R. So number two, name any other point on the ray. You could use through RZ or RA or RW. And then three, here's the weird rule. We always pretend like it's going to the right, even if the picture shows it going to the left, or if the picture shows it going up, or if the picture shows it going down or diagonally. And the reason we do that is because we don't want to have a different set of rules for naming an array that goes left or right or up or down. Have four different sets of rules, then what do you do if it's slanted? So we have one rule. Pretend it's going to the right. So we always name it with the endpoint first, in this case R, and then any of the other points, and we draw the ray symbol above them going to the right. So this is ray RW, or ray RA, or ray RZ. Next, we're going to start talking about angles. This is an angle. The way we describe an angle is it's two rays with the same endpoint. There are two rays making up one side and the other side of the angle to share this endpoint. That shared endpoint is going to be very important when we talk about angles. It's got its own special name. It's the word vertex. I know it sounds like a sci-fi movie. A vertex. That word's going to come up over and over all year long, so you commit to knowing that one. The word vertex basically means corner in geometry. It's where two things meet each other. It's the point where they meet. All right, so for each of these angles, which point is the vertex? Let's just take a look at the first one. What's the vertex in the first one? What's the vertex in the second one? What's the vertex in the third one? And it's B in the first, D in the second, J in the third. Okay, an angle has three parts. It's got two sides and a vertex. That's how we describe the parts of an angle. But it cuts up space into two locations as well. We always have an interior of our angle and an exterior of our angle. Hopefully you know the word interior. You've heard it before. Interior of a car is the stuff inside a car, or an interior decorator is someone who decorates inside a house. Interior means stuff on the inside of the angle. It's in the smaller part of the angle. If this is the inside, then everything else is what we call the exterior. That means outside. To name an angle, just like naming rays and segments and lines, we have a specific rule for it. Now, in this case, there are steps, and it'll make sense basically in a second, but here are the steps. You pick a point, say I wanted to give the name for this angle. I'm going to pick a point on one side of it. I could start with R, or I could start over here with S. Then we're going to name the vertex. The vertex is point Q, and then name the point on the other ray. In other words, you're going to basically tell the points in the order you would connect the dots to draw the angle. So I could start at R, then go to Q, then go to S, or we could start at S, go to Q, and then R. So we could write either one of these would work. I could start at R, I could start at S, but either way, the second point is always the vertex. It's going to be Q, and then a point on the other side. Lastly, we draw an angle symbol in the front. This is how we name an angle. This says, down here, this says angle RQS. This is angle SQR. They are the same angle. And again, the key way to think about this is you list the points in the order you would connect the dots to draw the angle. That makes the vertex always second. And then don't forget the angle symbol out front. So for example, if I gave you this picture, there are two names for this angle. Can you find those two names? And again, you're connecting the dots. You're giving the order to connect the dots. It's ABC or CBA. And we write the angle symbol out front of that. Now, sometimes our angles are complicated. We have a whole bunch of angles that are sharing a vertex. And to make it simpler, we use a shortcut for naming them. We can just number the angles. We can say this is angle 1, and this is angle 2, and this is angle 3. If you see this in a picture, you can name them using that short way. Angle 1, angle 2, angle 3. We do this when our picture has a lot of different angles in it. Likewise, sometimes our picture is really simple. We have only one angle, and there's no other angles that share this vertex. In this case, we can just call this angle E, because there's only one angle with this, it's the vertex. Because of this, an angle like this might have up to 4 different names. We could call this angle, we could say WXY. We could call it angle, name it in reverse, angle YXW. We could call it just angle 3 because it's got the 3 label in there. Or since there's no other angle that shares this vertex, we might just call it angle X. Next, we're going to talk about types of angles. The first type of angles that we're going to talk about are what are called adjacent angles. This word adjacent comes up a lot in geometry. It just means next to. Adjacent angles are angles next to each other. They share the vertex, in this case point B, and then one of the sides, in this case ray BD. So adjacent angles are basically angles that are touching. They're sharing one side and the vertex. All of these are examples of adjacent angles. It's two angles that are sharing the vertex and one side. If our adjacent angles make a straight line, we call that a linear pair. That means a line pair, two that make a line. And it looks like this. We have one straight line broken up into two angles. And these are all examples of linear pairs. It's a straight line broken up into two angles. So adjacent means just next to each other, but if they're next to each other and making a straight line, we call them a linear pair. And then the last stuff that you might already be familiar with, right angles are angles that measure 90 degrees, exactly 90 degrees. It comes up often enough in things that we make that we have a symbol for that. That's when we have an angle that's making 90 degrees, we draw this little box in the corner, and that is a right angle. A right angle is a 90-degree angle, and we represent that with a little box in the corner here showing that it's 90 degrees. If you're not sure what I mean by a right angle, this is the angle your floors and walls are supposed to make with each other. All right. An acute angle is any angle that's smaller than that. See, here we have a 90-degree angle. Anything that's smaller, anything that's closer together where we have a smaller interior of our angles is considered an acute angle. And an obtuse angle is any angle that's more than 90 degrees. Anything that goes above 90 degrees, somewhere between the right angle and a straight line, is an obtuse angle. Finally, a straight angle is one that's actually making a straight line. So we have an acute angle is less than 90, obtuse angle is more than 90, and a straight angle is 180 degrees, basically a straight line. So these are our angle types: acute, obtuse, right, and straight. Less than 90, more than 90, right is exactly 90, straight is exactly 180. If it's more than 180, well, we're not going to deal with that for right now. So, all right, so take a moment and try to decide if each of these angles is acute, obtuse, right, or straight. Okay, the last thing we're going to talk about are supplementary angles and complementary angles. They're very easy ideas, but the words sound similar to each other, so people tend to mix them up. This is worth writing down somewhere. Supplementary angles are angles that add to 180, and complementary angles are angles that add to 90. So a question that might come with the word supplement is, what's the supplement to 50 degrees? Well, the supplement is what I add to 50 degrees to get 180. So to find it, you just do 180 minus 50. In this case, that would be 130 degrees. The complement, almost the same idea, except it's 90. So what's the complement to 50? What angle do I add to 50 to get 90? Just do 90 minus 50 to find that. In this case, that would be 40. The biggest trouble people have with these is remembering which one is which. These problems can get a little bit harder, but we'll talk about those in the next few days.